Okay, in the beginning, I would like to say something more. For some people, is to remind, for some, just share the knowledge about the key fuel properties. First, I would like to mention about the analysis state, because every time when we present the numbers of the fuel, the parameters, we have to say about the analysis state, because the number can be shown in the as received state. That means that we analyze the fuel that is, let's say, without any processing, with the moisture, with the ash. Of course, we can assume that the fuel can be dry in air, not in oven, just in air, and take a balance between the moisture in air and moisture in the fuel. And we call it dry air. Sometimes in our system, we call it analytical state. The next step, if we put the fuel into the oven and dry it and remove all the moisture, we call it a dry state. And if we assume that we can remove the ash, we call it dry ash free state. Of course, we can calculate very easily from state to state. However, we have to have the specific parameters, especially moisture content and ash content, to calculate between as received to dried. Doesn't matter. We can easily do it if we have specific and well-known parameters. The next important thing is, of course, the calorific value, but we can distinguish between lower heating value and the higher heating value. Let's say the scientific definition looks very easy, that a lower heating value is the heat if we consider the combustion of the fuel portion, and we cool down the flue gas. We can take the heat and cool down and just below the room temperature. We can say that we take the lower heating value. This is the heat of the lower heating value. But if we can recover the heat of the water evaporation, we have higher heating value. Of course, this higher means the higher value. However, sometimes the engineers ask us, well, but is it possible to do it in the industrial scale, industrial processes? Maybe it is on a paper or just only in a book. Of course not. We have some example of the installation in Polish CHP plant. You can see here is the heart of this system. When the flue gas is quenched and the water vapor is condensed, and as a benefit is additional heat that we can recover. And as I said, it is really operated, it is installation operated in a reality. It works now. So I would like to reply that in some solutions, it is possible to recover the latent heat of evaporation in industrial scale installations. Okay, so of course, these solutions have a few benefits. Let me shortly say about that. Of course, we recover energy, we have a higher efficiency, lower CO2 emission. Also, we can obtain the lower emission of particulate matter and the sulfur dioxide, because if the particles are wettable, it can be captured in this equipment. And the main byproduct is a salt, because sodium base is used as a main component. Another benefit, very beneficial point, is to protect the flue gas pipeline against the corrosion by crolites. Extremely important for agriculture biomass. If we use the agriculture biomass that have usually high content of chlorine, it protects the flue gas pipelines. Okay, the next important parameters we call it proximate analysis. It is sum of moisture, volatile matter, ash, and fixed carbon. But what does it exactly mean, these specific parameters? Again, let's consider the combustion of the fuel portion, but now we consider only the solid fuels, the coal or biomass. So the first step, if we put the portion of fuel into the combustion chamber, the first step is heating and drying. So we remove the water. It's very obvious. But the next step is a release of volatile matter, ignition of that, because the volatiles consist mainly hydrocarbons, that it is a very flammable, let's say, mixture. So after ignition, we can observe the quite big flame. And if we, let's say, use all the volatile matters, the next step is char combustion. And final step, reasonable, is production or receiving of the ash. But from the practical point of view, from the power plant engineering point of view, what does exactly mean this every specific component? The moisture, the motto is reasonable. More moisture means less energy. Volatile matter, in our opinion, very important, let's say extremely important parameter, sometimes forgotten. In my opinion, even more important than calorific value, because more volatile matter means easier ignition, especially for pulverized boilers. If the volatile matter in the coal is too small, even we have higher calorific value coal, we have serious problem with the combustion control, because less volatile matter means more problems with the ignition. The ash, let's say the quantity and the composition are important in terms of different processes. Let me say more about that in the next seminars, because the next webinar is about the ash related issues. And the fixed carbon, more fixed carbon means more energy. What is, let's say, the main difference between coal and biomass if we consider the proximate analysis? Usually the coal has a more fixed carbon and the less volatile matters, and the biomass has more or less 2 times more volatile matter, more or less 3 times less fixed carbon, more moisture, and less ash. But it is some exception, the paddy straw, because the paddy straw has very high content of the ash. Another important key fuel parameters is, we call it ultimate analysis. If we consider air dry state, it is sum of carbon, hydrogen, nitrogen, sulfur, oxygen, ash, and moisture. Or if we consider only the dry ash free, it is a sum of carbon, hydrogen, nitrogen, sulfur, and oxygen. And again, the question is, what does it exactly mean in the co-firing practice? So the more carbon and hydrogen means more energy, more nitrogen, it means more nitrogen oxides emission, NOx emissions. More sulfur is more sulfur dioxide emission, and the more oxygen means less energy. The next important point, especially for the agro biomass, is the ash composition. So if we consider that we only analyze the ash, let's forget about the volatile matter, fixed carbon, and moisture, just only analyze the ash. We can analyze the many components, but the usually detector, you can the list of usually detected compounds. Of course, the green market are rather desired. It is good if we have more, for example, magnesium or calcium, but sodium and potassium, there are not desired problematic compounds in the ash.